This is how we see the street while sitting in our car, effortlessly glancing at it and immediately recognizing cars, pedestrians, and traffic lights. We don't think about it, it just happens. But this is how the self-driving car you're sitting in sees the same street. It doesn't just look, it analyzes, labels, and understands everything in real time. By the way, did you notice the number plate in this picture at first sight? No, right? But your car noticed it. That's what sets computer vision apart from human vision. Now imagine something that goes beyond just recognizing objects. One that can reason, make decisions, and interact intelligently with the world in real time. That's the power vision AI agents hold. But what sets them apart from traditional computer vision models? What are the components operating them, and where are they making an impact? More importantly, what challenges must they overcome to truly revolutionize industries? Let's find out. No doubt, traditional computer vision is powerful, but it's limited. The moment it encounters something outside its training data, it fails. Also, it is not suited for tasks that require speed, since labeling millions of images manually is difficult. But vision AI agents? They're adaptive. Learning from real-time data, they contain three main components. Eyes vision models like YOLO V11 and SAM that detect objects in any condition, rain, glare, even through walls. Brains, use of language model like GPT-4 that understands text commands, find every SUV with out-of-state plates, action engines that do alerting cops, locking down streets, all in real time. And if they mess up, you just tell them it's 3, not 8, and it automatically fixes this error everywhere. Here's where it gets insane. In New York, cops used to spend days scrubbing footage for stolen cars. Now, vision AI agents scan 10,000 cameras at once, spotting even scratched-off plates, and send alerts before the thief finishes their coffee. And it's not just streets. In hospitals, these agents spot tumors invisible to the human eye. In factories, they predict machine failures by seeing the details the human eye can't detect. This is how a vision agent works. Just give the prompt and leave every other task to your visual AI pilot. But as transformative as these systems are to our society, they must navigate significant challenges like data privacy concerns, high computational costs, and biases from training data to achieve seamless real-world performance. So I'm leaving you with a question. How far is the time where vision AI agents complement human vision? For the answer and other insights, do check our blog on vision AI agents. The link is provided in the description.